Example 7. Most schools require students to have a TB screening before enrolling. The test involves an injection in the arm, and 48 hours later the test is read by observing the injection spot. If no bump is present, the student is TB free. This test is 99% effective. However, it is possible to have TB and test negative. This is more serious than a false positive, so let's assume this rate is 0.1%. About 0.005% of students actually have TB each year. What is the probability of having TB after testing positive? So to do this, we need to think of our conditional probabilities. 99% accurate usually means a false positive rate of 1%, or that 1% of the time you will get a positive test even though you don't have TB. And we know that the probability of having TB and getting a negative test is 0.001 as that was given to us. We know the probability that someone has TB is 0.00005, so the probability of no TB is 0.99995. On the bottom, we do put that probability of getting TB, which is 0.00005. So now we move to those conditional probabilities. The probability of given they have TB, they test positive is 0.01. The probability of given they have TB, they test negative is 0.99. That's where that 99% effective came in. On the bottom, we have the probability that given they do have TB, they had a positive test. And that's 0.999 because we set that lower bound at 0.001. And probability of given they have TB, they test negative, which is a big problem, is 0.001. Finally, we're ready for the ands, the no TB and TB positive, which is 0.0099995. The probability of no TB and a negative TB test will be 0.9899505. So we just multiply these through. That was 0.99995 times 0.99. Probability of TB and a positive TB test is 0.0004995, which was the 0.00005 times 0.999. Probability of TB and a positive TB test is 0.001 times 0.00005. So we have all those zeros and a 5. Now we're ready to write our conclusion. So the probability that given a positive test somebody has TB will equal the probability of TB and a positive test, TB intersection positive test, over the probability of a positive test. Now in this case, a positive test is no TB and a positive test, TB and a positive test. So this equals TB and a positive test, 0.0004995, divided by the probability of no TB and a positive test, 0.0099995, plus the probability of TB and a positive test, 0.0004995. This comes out to be 0.00497. So, the probability of having TB after receiving a positive test is 0.00497. So you have less than 0.5% of a chance of actually having TB if you test positive for it.